You can see my screen, right?
Yes, doctor.
Okay. Today's chapter is an easy chapter, and it's about program control instructions. It's easy chapter, but it's very interesting in the sense it's very useful to organize your program. So you'll see. If you go to your Logic Pro, for example, the software we mostly use, but you can see it at Do More, Designer, Siemens. They all have program control instructions. So on your Logic Pro, they are here. So you click on program control, you will find them, and this will be basically the learning outcome of our chapter. In different software like Siemens or Do More or RS Logics, you will find them maybe in a slightly different name, but you will still find them, like for example, jump to subroutine, it's called function in Siemens, FC, etc. So here it's called subroutine. Subroutine means a function, etc. Other things same, like jump, you find jump and label, you find them the same. In other software you can see go to instead of jump, you see go to, but all they have the same meaning. So it's about you how to practice. It's you practice software more, you look to the help, so you understand and master them much more. In those slides or this chapter, we'll focus on Logic Pro. Later on I may record for you a bit on Siemens, so to see the difference a bit between, but I'm sure after done with this chapter you'll be able to explore any software yourself. Just by looking to the help you'll be able to do the analogy in between. So we'll start by master control instruction, or the MCR. Here you can see it, this instruction. We'll start by this instruction first, is the MCR. Okay, so we are not gonna go by order. So the MCR, master control reset MCR instruction. You may saw it in hardware relay, and the PLC offer an equivalent to it. It's called MCR. So what's how to use a master control relay? It's simply a relay, but it has a master function. Sometimes you need to use it in relay circuit. It's a simple relay, but it has a master function, where its function is to provide input and output power shutdown of an entire circuit. Like basically when it is activated, this will be open, and therefore no current will be passing on this entire circuit. So basically it's used, so you don't need this in all cases. So if you cut from one side is enough. So then if all the circuit will not turn on, will not work. So this is a master control relay basically used in hardwired relay circuit. So basically it has a function to provide input-output power shutdown. Okay, so something similar we'll be using in PLC. PLC manufacturers offer a form of a master control relay as part of their instruction set. Okay, we'll look at it. The MCR clears all set non-retentive output ranks between the paired MCR instructions. So just I want you to keep attention to this word, this sentence, and return to it at the end of the chapter and see yourself if you understood what it means or not. Okay, at the end of explaining of this instruction, you go back to here to see what it means. Clears all set non-retentive output ranks between the paired MCR instruction. And this sentence is a good sentence as well, because the MCR instruction is programmed For safety reasons, it should not be used as a substitute for a hardwired master control relay, which provides emergency input-output power shutdown. So here they are telling you, even if you use MCR, you still, in a real application, you still need to use emergency input-output power shutdown. The emergency button is always used in any system. So this doesn't replace, it's not a substitute for your emergency input-output button. Just as a note, okay? So this sentence, it's basically what it means and or how it works, MCR. Let's see it via examples. Okay, let's take this example. In this example, I have a motor, I have pilot light 1, and I have solenoid. So this is a motor, and this is the pilot light 1, and this is my solenoid. Okay, this is my solenoid. So please look at the solenoid. Solenoid, it has a latch and unlatch, or set and reset in Siemens. We call them set and reset. If you look at them, this is a retentive output. This output is a retentive, right? Like when you use a retentive timer, etc. It saves the bit. It saves the time if it's a retentive timer. So when you switch the limit switch on, it goes on. When you turn limit switch 1 off, it's still on. Solenoid still on until you reset it, and therefore it goes off. So those are a retentive output. So what will happen in your program? So what do I have at the input? At the input, I have manual switch on off. I have normally closed, stop push button, normally open, start push button. I have a level switch, liquid level switch, something like floating switch. I have a limit switch 1 and 2. One is normally open and one is, it works as a normally closed switch. Okay, so where is the MCR and how I work with the MCR? So here is your MCR. You see, it has an open and line. So assuming you have rank in between and maybe rank after. So right, this is not the end of your program, but everything in between the MCR. So MCR, it always came in paired instruction. Paired MC, that's what we mean by paired MCR instruction. So it comes in pair. You end up here. You don't need to have a condition and. You can have a condition and, but you don't need. So that start and end. So you need 2, and everything in between is belong to the MCR. When it is activated, what will happen when the MCR is activated? If it's not activated, so what you should know, if the MCR is not activated, so the program work as usually, as if this instruction doesn't exist. As if this to rank doesn't exist, the program will work normally. When you open it, when you turn on this switch, so then a flow will go in this rank. What will happen?
When you turn off, the program will shut down.
Well, what will happen is the following. So what will happen is, assuming your motor was on, and your pilot light 1 was on, and your solenoid was on. So all the output were on. So what will happen is, using the MCR, when it's activated, what happens is the motor will go off, will de-energize, and the pilot light will de-energize, but the solenoid will still working.
On until we reset.
No, even now, if you reset it, it's not. It's still, it will still working. It's nothing will be affect your output. So when you activate it, your program will jump directly to the following rank after the MCR, will not taking care of anything here. It's not gonna take care of anything here. Even if now you start, even if it was energized, will be de-energized. If you re-energize again, it will stay off. So when MCR is de-energized, all non-retentive outputs de-energize. When MCR is de-energized, all retentive output remain in last state. The retentive output, when MCR is energized, so when MCR is energized, all retentive outputs remains in the last state. If they were on, they stay on. But all non-retentive output will de-energize. Is it clear? So what's later on in the lab, you need to apply it. You apply this one in your Logic Pro, so you have hands-on on it. Okay. Any question regarding the MCR? So understanding by applying is really important. You need to do it at your lab session Friday. Jump instruction. So jump instruction also, it comes in pair, but this time you don't use MCR at the beginning, at the end. The jump instruction, you use it with a label. Okay, the label tells you where to jump, at which rank you want to jump. Let's see it in action as well. Let's see this example. So here it's a simple example. You have push button and switch, and you have 3 pilot light, red, maybe orange, and green. Okay. So you have 3 pilot light and push button and switch. When you press the push button, light 1 will go on, and light 2 will go on, and also light 3 will go on. So you see, when you press the push button, PB, this PB, it is here and here and here. All the light will go on, PL1, PL2, and PL3. This has no any logic effect. Has no logic effect, as if it doesn't exist. This is the label. If you put a label like you are putting a name or so, it has no logic effect. It's a label, just label, and the name said. And label is like you are naming the rank, as simple as that. So labeling, it has no logic effect. It's as you are naming the rank itself. You are naming the rank by Q2 0. You can name it any name like cat, flower. I mean light. You can give it any name. Okay. You can call it anything. But so here the program is very simple. Switch is off. The switch is off. The switch is off. So the jumping effect doesn't exist. So now when you press the push button, all the light will go on. Now I close my switch. When I close my switch, so the program will. So what will happen now when I press the push button? Pilot light 1 will go on, and pilot light 3 will go on, and pilot light 2
will be off.
Will stay off, will never be on. If you keep pressing your push button, your scanning program, your program will reach the second rank and jump to the force to here. Directly jump from here to here. So then your program is not going to execute the third rank. Okay, so also this you need to try at your lab. You can also jump to jump from 2 different places. Okay, maybe I want to call it cat 1 and cat 2, or it's the same, QT. Okay, cat 1. So you maybe jump from 2 different places. If you activate input A, so you may jump from here. If you activate input D, so then you jump from here. So if you jump from here, so means everything here will not be executed. So this is different than the MCR. And MCR is gonna de-energize all your non-retentive output and keep the last state of all the retentive outputs. So means, but here the jumping instruction, you just jump from here to here, is as if all those doesn't exist.
Skipping all the
Yeah.
the ranks that are not related to the label.
Yeah, that's what will
It's not
happen
related.
when your switch is gonna on. So this rang as if it doesn't exist. Okay. So what? So let me ask you this question. So what if? Well, at the lab you will try. I will ask again at the lab. But what if? So ask to yourself, and maybe you try before Friday. What if I don't have here push button? I have switch. Um, I have switch, and then my switch is off. Maybe this is switch 1, and this is switch 2. Okay, so if switch 1, sorry, if switch 1 is on, so then the light will stay on. So now what I do now, I go and I jump. When you I go and I switch my switch 2, I close my switch 2. So now I jump from here to here. So pilot light 2 before jumping was on. Is the status of it will change or not, or will stay on?
L2.
So I want you to think about this question for Friday. I will re-ask on Friday again, so you apply as part of your homework. So then you
Because
understand. Yes.
if you replace the push button by a switch,
Yeah.
it will become a retentive. Yes.
So let's discuss it on Friday again, or when you rewatch the video, you may get my point. Good.
Okay, Doctor.
So now
The
we'll
switch,
talk.
Doctor, bس a question. The switch
Yeah.
should be normally closed or normally open?
But again, we will talk about it on Friday.
Okay.
Subroutine function. So the third thing I want you to learn. So now we learn MCR. We learn jump and label. They come together. You jump to a label. Your jump, you need to give a name for your jump and the same name for your label. So then you know where to jump, to which rank you want to jump. So label is the place on which you are jumping, and jump is from where you are jumping. You jump from maybe rank 2 to rank 4, etc. So now we will learn those instructions. Also, those instructions, they come together and we use them together. Those instructions is basically to make your program more easy to read. And they called in Siemens like a function, if you wish. It's kind of function. I may present it to you later on in Siemens. But because you are using this software at home, so that's what I want you to know, how to use them in this software: GSR, RET, and SPR. So GSR is called jump. So as here, jump. But now you are not jumping in the main program as here. You are jumping to another program. You are jumping to a routine or to a function. Routine means a function. You are jumping to a sub-function, they call it subroutine. So to another program in which you do some task, then return back. So then you jump to a designated subroutine instruction. You return from the subroutine. That's how you return from the subroutine. Exits current subroutine and returns to previous condition. Identifies the subroutine program. So here is to identify the subroutine program. Let's see them in action. That's how the three instruction work. So in your main program, you have this main program. When this instruction is on, so here you use jump to subroutine. Okay, at this rank. So then now I'm not, your program will not scan this rank and this rank and this rank now. Your program, when they see this instruction is on, they will jump and execute those rank. Okay, so here you use the subroutine, the second one. And the third one, return, use it at the end. So at the end, when your program ends the subroutine, he will see the return instruction. So it will return to your the rank just after the GSR or the jump to subroutine and execute it. So now, so you see, it's like a function executed at your demand. When you demand it, when you want it, it will be executed. It could be here always high if you wish, so you have no condition or instruction to execute the function. Okay, so here is the same example. So it's your main program, it's your subroutine. When it's executed, it goes here, then you return, and you start from here. Okay. Also, it could be nested. It could be nested like this. For example, you execute the jump to subroutine 3. So here, file 3. Okay, here is file 3. Then you execute here, and while going, assuming this instruction is on as well, so then you go to subroutine file 4. So this is file 4. You executed on here, so then you go to subroutine 5. So then this is, we call it nested. And here you don't have any extra sub function, subroutine. So you have a return. You return from where you call it. So you return to here. Then you return to here and continue your program. Let's we call it nested subroutine. In your Logic Pro, the file is called U3, U4, etc. So here you put U4 like this. So you'll see when you practice on Logic Pro. So forcing external input and output. So now we still have actually few instruction we didn't talk about. Basically, we're done with jump label, jump subroutine, return and subroutine, MCR. We still have these two instruction. So I should talk about them first, then I go to other thing. So we still have two instruction in program control. Let's talk about them. Okay. These two instructions are temporary end instruction and the suspend instruction. Well, let's see the temporary end instruction first. Temporary end instruction is used to progressively debug a program. So to progressively debug a program or conditionally omit the balance of your current program file or subroutines. When rank conditions are true, assuming you have true conditions here, all the conditions are true, this instruction stops the program scan. Temporary end instruction means that this instruction stops the program scan, updates the input and output, and resumes scanning at rank 0 of the main program file. So this instruction is used for debugging, for progressively debug a program. Okay, so you can imagine, I'm not sure if I have an example. Yes, here is an example. So you can imagine you are using it here. So means you are temporarily ending your program here. So now your scan will go from here up to here. When he's seeing this instruction, if it is on, if the switch is on, so then your program will go to the first rank again, then come back. So then your program is only this. Your CPU or your PLC is not regarding everything here, is not seeing anything here. Okay, that's the temporary end instruction. So and it's used to debug your program basically. So you start debugging from here to here. Then if it is correct, so you take this from here and maybe you put it here. Maybe you put this instruction here. T and D. Then you will debug the remaining part, etc., etc. You continue progressively debug your program. You can move it progressively. You can program the T and D instruction unconditionally, or you can condition it with a switch, or you can make it unconditioned. Okay. So the programs that you will try, also, of course, any instruction we used, you will try in the lab Friday. Suspend instruction with some exercises related to it. Suspend instruction. What this instruction is about? This instruction is used to trap and identify specific conditions during system troubleshooting and program debugging. So it's the last instruction in your program control, and it looks like this. You should identify an ID, and here we go. When the rank is true, the suspend output instruction places the controller in the suspend mode. That's what happened actually. Your controller now in the suspend mode, and the PLC immediately terminates scan cycling. Immediately terminates scan cycling. So now when this is on, in whatever rank it is, your PLC will be in suspend mode and will terminate scanning. Just not like temporary end instruction. Temporary end instruction, it's like you are reaching the end of your program. Even so, if you are not actually at the end of your program, but your PLC will ignore anything after the TND and will go and start the scanning from rank 0. But suspend, it is on hold. So now your PLC terminates scan. It's not scanning anymore. It's not gonna return to rank 0. No, it's not scanning. It's on hold. That's what the instruction do. So all ladder logic output. What's the effect of this instruction? All ladder logic outputs will be de-energized. All the ladder logic outputs will be de-energized. But if you have something in status files, like in memory, etc., they stay. They will not change. But just if you look to your output, will be all de-energized. That's how the suspend instruction work. The sus or the suspend instruction writes the suspend ID number. So you give an ID number for the suspend instruction as it executes. So you can include several sus instruction in a program, each with a different suspend ID. So we end them here. I will open my Logic Pro. Okay. Just in a waiting time I will explain two more instructions which are belong to program control instruction, but they are not in the menu of it. So forcing external input output addresses. So what it means is, and why we do need it. Forcing, so you will learn forcing in your lab when you apply. Yes, let me, why doing this? Anyway, forcing external input-output address. Forcing allows the PLC user to turn an external input or output on and or off from the keyboard of the programming device. From your PC, you can turn an external input or output on and off regardless of the actual state of the field device. That's what we mean by forcing. Maybe your switch is actually on, but you go to the status file and you force it to be off. Maybe your output is off, and you go to the status file and you force it to be on, regardless of the actual state of the field device. That's what we mean by forcing on and off. Okay, it doesn't want to go, it's alright. Here is an example, like forcing an input on. That's your input. Input should be 0 because the actual state of the input device 0 ignored, and you force it to 1. So what you do is you force it to be 1. So programming terminal forces the state of input to be on, to be 1. So force enable, forces exist, and force enable. You will see that in your Logic Pro, and therefore you make it 1, and then my switch is on, is 1. Force is on, you see. So it will give you this indication like force on. All right, even if it is off. So you need to apply it and get trained on it in your lab Friday. Forcing an output on. Same way, so you can force the output to be on, like here is forces on. When executed, you will understand it more. Good. Yeah, that's it for this chapter. Basically, those are
From
your...
where,
Yeah, yes.
from where can we get this instruction in Logic Pro?
Yeah, so in Logic Pro, from the program control menu, so you go to the menu here, and you go to
Force.
the... Yeah, I understand. Okay. So for forcing an input, for example, you are here. So if you go to the data table, you are here. You see, that's my data table. If you click on forces, so here, for example, it depends what is the address of this. So you go and force it. Okay. That's input forces. You see input force. So you force it this way. Good. On Friday, I'll be happy to answer any question regarding to the practical side using the software in case you have questions. So I will be live with you as always. I present the lab to you and I'll stay with you. So any question related to the use of any instructions, in case you didn't figure it out yourself, you will ask me. Good. I will now present to you